we've covered every possible case, right? Distinct roots, multiple roots, and complex roots. Okay, let's do some examples on complex roots.
Professor?
Yeah.
You're saying with the constants,
Yeah.
those just becomes a real constant, and then the other one, when you add the I, it just becomes a real constant?
Yeah, because what happens is that take a number, take away its complex conjugate. You'll see that it's, here, I'll just do it for you. Suppose I have C1 is equal to 6I. The C1, say, is going to be 6 plus 5I. You don't have to, C2 is going to be 6 minus 5I, right? What's C1 minus C2? It's going to be 10I, right? And then you get 10I with I, you get minus 10. So we have the solution now in terms of these real quantities. Okay. Complex roots. I have two examples here. Okay. And again, remember, we're talking this whole time about linear differential equations, homogeneous, right inside zero, constant coefficients, okay? Not variable coefficients. Clearly, after we finish this, the next logical topic would be what? The inhomogeneous equation. Okay. So let's look at the first example. Example one, in the sense of the first example with complex roots. Suppose I have the differential equation, second derivative of y with respect to x, plus 4dy dx, plus 7y equals 0. Okay. So we got y double prime, 4y prime, 7y equals 0. Okay. Second order equation, great, constant coefficients. We can write down our characteristic equation, r squared plus 4r plus 7 is equal to 0. Right, that doesn't factor, we'll have to use the quadratic formula. Negative 4 plus or minus the square root of 16 minus 4 times 7 all over 2. Right? Yeah. So that becomes negative 4 plus or minus the square root 16 take away 28 to 12, right? Over 2. Let me just write that as negative 4 plus or minus 4 times 3, which is 2 radical, 2i radical 3 over 2. Right? So I just make 12 4 times 3, that becomes a 2. And if I divide finally, I'm going to get negative 2 plus or minus I radical 3. Okay? So the roots, as you can see, are complex conjugates, as we expected. Negative 2 plus or minus I radical 3. Well, that's in the form alpha plus I beta, alpha minus I beta. So you can write the solution immediately as y of x, some arbitrary constant, right? For the first one, let's say it's e to the minus 2x. Doesn't matter if you use sine or cosine. Sine of radical 3x. Plus another arbitrary constant. What's the second solution? It's still e to the minus 2x, but now the sign becomes a cosine of radical 3 times x. And of course, you can factor out e to the minus 2x if you wanted to. Okay? And again, you can easily verify that both e to the minus 2x sine radical 3x and e to the minus 2x cos radical 3x, if you plug them in and simplify, you would get 0. Okay, let's go to a third order equation. Again, usually what happens is you get combinations of this thing. You'll get some real roots, some complex roots. You may get complex, real, and some repeated. But we did all those cases, so we know exactly what to do. Let's do example number 2 now. Complex roots. third order equation. Third derivative of y with respect to x minus 2 dy dx, minus 2 times the second dy dx. There is no second derivative here. Plus 2y equals 0. Okay, so the equation is the third derivative of y with respect to x minus 2 dy dx plus 2y is equal to 0. Actually, so I think this one is easier than the other one. But is it third? Let me just... Oh, sorry. It's the second derivative. It's also second order. Second order with respect to x minus 2 dy dx plus 2y is equal to 0. Okay, characteristic equation. R squared minus 2r plus 2 is equal to 0. Again, it doesn't factor, so we'll have to use the quadratic formula. R equals 2 plus or minus the square root of that square minus 8 all over 2. The square root of 4 minus 8 is the square root of negative 4, which is 2i. So you get 1 plus or minus r. Okay, so the solution, this is easier, right? Is C1 alpha plus or minus I beta, great. E to the x sine x plus C sub 2 e to the x cosine x, where C1 and C2 are arbitrary constants, real. Okay? Okay. Well, for the fun of it, should we just like, you know, let's verify this, because it's not too bad. Let's verify e to the x sine x, okay? I'm just going to show that e to the x sine x actually solves the equation. Okay, so we'll say let y1 equal e to the x sine x, okay? Let's differentiate. y1 prime, you're going to pick up e to the x, I guess e sine x, and then plus cosine x, okay? Right, but differentiating product will again, e to the x cosine plus e to the x sine. Okay, the second derivative, y1 double prime, you do the product rule again, you get e to the x, differentiate here, get cos x minus sine x, right? Differentiate sine plus cosine, you get cosine minus sine, and then derivative of x is just e to the x, parentheses, sine x plus cosine x. Let's see if we can simplify that. Pull out an e to the x. Again, e to the x cosine x, e to the x cos x, so it looks like a 2 cosine x, right? And then minus e to the x sine x plus the x, that's it. Okay. Hope I didn't make a mistake. Okay, let's plug in y1 prime, y1 double prime, and see if it goes to 0. Okay, what's L operating on y1? I need y1 double prime, which if I didn't make a mistake, is just 2 e to the x cosine x, right? Did I make a mistake? Hopefully not. Okay, 2 e to the x cosine x. And then I need minus 2 times y1 prime. Minus 2, y1 prime is right over here. E to the x sine plus cosine. Okay, and then plus 2 times y. Let's just say that's going to be 2 e to the x, C1 sine plus C2 cosine. Okay.
Is y1 not e to the x sine x?
Which one did I do?
Yeah, the last one.
y1 is e to the x sine x.
Oh, yeah, okay. Plus 2 times y, right? Here's y. Oh, y1, you're right,
Right.
just e to the x sine x, thank you.
Because we're just plugging in for
That's
y1
right.
here, right? Not
Very
y2.
good, yeah. So I get 2 times y1, which is e to the x sine. Okay, let's see if we can get some cancellation over here. Yeah, I see 2 e to the x sine minus 2 e to the x sine minus 2 e to the x cosine plus 2 e to the x cosine. Yeah, equals 0. Okay.
And then if we did it for y of 2, it would just be with cosine?
Yeah, same thing would happen. Like that's always good, you know, if you have time, like an exam, you know, but you have to, you know. Okay, so that's, that was example number 2 for the case of complex roots. Okay, just have another, I have a few more examples here. Okay, so please, before I go, I'm going to go to the next topic today. Okay, so it's going to be covered, you know, quite a bit today. Basically, we exhausted the whole topic of homogeneous differential equations with constant coefficients. I should say we got to, you know, how to get those solutions at least. Okay? So it'll probably be a homework assignment waiting for you. Okay. Let's see. Let's try this one. Some further examples. Okay. Suppose I have the equation 4 times the second derivative of y with respect to x plus 4 dy dx plus 17 y is equal to 0. So again, that's 4y double prime plus 4y prime plus 17y equals to 0. Oh, this is an initial value problem, actually. Okay, so and then we have the initial conditions. Y of 0 is equal to -1, and y prime of 0 is equal to 2. Okay, so I want to find the solution of that differential equation, 4y double prime plus 4y prime plus 17y equals 0. And the initial conditions is that it should have a value at 0 of -1, and its derivative at 0 should be 2. We should be able to get a unique solution for this, right? No arbitrary constants. But the procedure, of course, is always the same. First, forget about the initial conditions for the time being. Look at the homogeneous equation and get your 2 independent solutions. Okay, so we're going to have 4r squared plus 4r plus 17 equals 0. Probably 17 is not going to be a missing number. 4r squared plus 4r plus 17 equals 0. Okay, let's use the quadratic formula. -4 plus or minus the square root minus 16 times 17. I see why they did that. Over 8. Everybody agree? 4 plus 19 is 3. Minus 4. Yeah. Okay. So the roots, so we get complex stuff here. -4 plus or minus the square root. Everybody see that's going to be 16 parentheses 1 minus 17 or -16 squared, right? Sorry. Negative of 16 squared, it's negative in there, divided by 8. Let's divide through. We're going to get -1/2 plus or minus 2y. So the general solution, y of x, okay, would be C1 e to the minus x over 2.
Should that be 1/2 I? Oh, never mind. It's squared.
Yeah, because it's 16 squared. Cosine 2x plus another constant e to the minus 2x, e to the minus x over 2, sorry, cosine 2x. Since we have to differentiate, I think we should probably simplify this somewhat. Yeah, let's just write this as y of x equals e to the minus x over 2, and put all this stuff inside. C1 cos 2x plus C sub 2 cos
Sine, yeah.
sine. Yeah. So 2 sine 2x. Okay. Let's plug in the first initial condition. What do we know? We know that y of 0 equals -1. So with this solution, the value of y at x equal to 0 is the exponential 0 is 1, and that goes out. So I get c sub 1. That has to equal -1. Okay? And all I have to do is get c sub 2 from the other initial condition. Unfortunately, I've got to differentiate, right? of x gonna be? Okay? Okay, let's do, we have e to the minus x over 2. If I differentiate inside, I get a minus 2c1 sine 2x plus 2c2 cos 2x. Right? Using the product rule, right? And then I have to differentiate e to the minus x over 2, which is minus a half e to the minus x over 2, and then just the stuff in parentheses. c1 cosine 2x plus c sub 2 sine 2x. Okay. And now let's just get y prime at 0. Okay, what's y prime at 0? That becomes 1. That gives me 2c2, right, from that guy. And then from here, I get minus a half times, plug in x equal to 0, I get c sub 1, right? And that has to equal, what's y prime at 0? That equals 2. I know the value of c sub 1. C sub 1 was negative 1. So 2c2 equals 2 plus c1 over 2, right? 2 plus c1 over 2. What's c1 over 2? Negative a half. 2 negative a half, it's going to be 4 halves minus 3 halves, all right? So c sub 2 is 3/4. Okay, actually got that right. Okay, so finally the solution, y of x of this initial value problem is equal to, let's just go to our general solution. Let's pull out e to the minus x over 2. Okay, I'm using this line right over here, pulling e to the minus x over 2. It's c1 cosine 2x. What was c1? Negative cosine 2x. Okay, and then c2 sine 2x plus 3/4 sine 2x.